Involving children in exercises where they must gather and organize numerical data is an important goal for teachers in elementary schools. Planning and conducting these activities is challenging and demanding. Let's see how Sue Brush, a second-grade teacher, attempts to involve her students in a problem-solving activity designed to reach these goals.
I'm planning for a party in the classroom, and when I was doing that, I thought of a question came to my mind, and I thought maybe you could help me solve it today. I need to know how I can figure out the class's favorite kind of jelly bean. And if you can help me out with that, raise your hand.
You could say red, and the people raise their hand if they like red, and you count, and you put it down on that chart, and you go to next color, next color.
That's a good idea, too. What would happen if we had somebody in the classroom that has never tasted a jelly bean before? How would we get information from that person?
Give them one.
Give them one.
Sue asks for some additional ideas, and the class decides that they should all be given several different jelly beans to taste. Having anticipated the students would suggest that, Sue prepared samples, which she distributes to them, and they begin tasting the jelly beans.
You may begin. Candy for math. You can't beat this. Please remember to taste all of the jelly beans first, and then go back and rank your jelly beans. So your pencil should be down. Okay, wait and share your information with us in just a minute, okay? Justin's still working. Okay, and put your name at the top of your jelly bean tasting sheet, please. Oops, Josh is almost finished. I'm going to collect the baggies at each table and just let you keep your... Thank you. Because I know what'll happen if you guys keep them. Raise your hand, please, if you can tell me what we can do now that we have this information. How can we organize it so that we can look at it as a whole group? We want the favorite flavor jelly bean. Jacinta.
See how much people like the same one and see how much people like other same ones.
Okay. Can you add? Can you add to that, Josh?
Write your names down. See how many, like, black, number one of that.
Okay, Josh, that was right in line with what Jacinta said. How many people have a number 1 next to black? And then we can collect the information that way. Okay, here's what we're going to do. Stacy and someone else, when we first started off, mentioned that we could graph the information. And so we have set up here, we have an empty graph up in the front of the room. Yes, Justin?
Sue then gives the students directions about how to show on the graph which jelly bean was their favorite, and they get ready to come to the front of the room to indicate their preferences. That's when Sue asks one of the tables to come up.
And I'd like table 4 to come up first, please. Okay, Robert, look at your card, find your square, and we'll get it up there. Can I see, did you bring your jelly?
Mine was green.
Okay. And then take your seat, and you can watch as we call other tables up to enter their information. Make sure your pencils are down. The next table I would like is table 1. I need your attention back up here, please, for just a moment. We collected the information. We've organized the information up here on the graph. Now we need to analyze and look at the information. And I need you to tell me what it is that we know by looking at the graph up here. What do we know? Please look at the graph up front. Candace, what do we know? Okay, Candace said most people like the green jelly bean. Candace, how many people liked green? Nine people liked green, and how did you find that out? Can you go up there and show us how you read the graph?
By looking at this.
Okay. It's where the top of the bar ends, and so 9 people liked the green jelly bean. All right, what else do we know just by looking at the graph? Justin? Thank you, Candace.
There's 3 people that like black and 3 people that like white.
3 people like the black and 3 people like the white. Okay. All right, what else do we know from looking at the bar graph? Andrew?
There's only one orange.
Only one person picked orange. Timmy?
And one person picked pink.
And one person picked pink. Okay. How many more people liked green than red? How many more people liked the green jelly bean than the red? Okay, so look up at the graph and try to find out the information, set up the problem, and then we'll see what you come out with. You have to have a problem set up on your paper. Quite a few hands, and some people are still thinking. Okay, set up the problem now. How many more people like the green jelly bean than the red? Problem now. How many more people like the green jelly bean than the red? Okay, try it. Okay, now I'm looking for a volunteer to share an answer with us. Dominique.
9 plus 5 is 14.
Okay, Dominique has 9 plus 5 is 14. Let's test it out. Dominique, come on up here. Okay, we want to know the difference. We want to know how many more people like green than red. And you say 14 people, 14 more people like green. Does that work?
9 take away 5.
She got up here and changed her mind. Tell him.
9 take away 5 is 4.
9 take away 5 is 4. So how many more people liked green than red? Carlos.
4.
Good. 4. 4. The key was you had to find the difference between the two numbers. Okay? Raise your hand if you can set up a problem like that, like I just set up, and ask the whole class. Okay, Jacinta. Looking at the information.
You can take pieces of paper and get all the kids' favorite colors.
Oh, I see. Let me stop you for a minute. You're giving me a different example of something that we could collect information on and graph. Okay, let's look at the one we have up there, though. Could you just think of another problem that we could ask everyone to figure out?
How many more reds there are? How many more people like red than black?
How many more people liked red than black? Go ahead and do it. Timmy.
2.
2. And how did you get your answer? What problem did you set up?
5 take away 3.
5 take away 3, and he got 2 for his answer. Good. Okay. I have one more question, and then we'll switch gears a little bit. How many people participated in this voting? Matt, how many people?
24.
24. How many people in the room right now?
25.
Is that where you got your answer? Or did you, what was the problem you set up?
How many people voted?
Okay, Matt said 24. Did anyone get a different answer? Let's see, we'll compare. I can't call on you if you're jumping up and oohing. Robert?
22.
22. How many people got 22 for their answer? How many people got a different number? Okay, so we have 24 and 22. How did you solve the problem? That's the most important thing, Robert.
9 plus 5 plus 3 plus 3 plus 1 plus 1 equals 2.
Where'd you get all those numbers from? Okay, so you added up each of these bars.
The highest one to the lowest.
He went the highest to the lowest, and your answer was 22. Okay, his answer was 22. And what could we do to involve more people?
Have a banner.
What do you mean?
Give ask people involved.
Around the school? Ask people? We could do something like that. What could we do that's even bigger?
Sue asks for some additional ideas about how to increase the size of their sample, and she uses those ideas to make a transition to small group work. During the group work, students will gather different types of information, which will be entered on graphs. Sue explains the center activities, gives the students directions, and they move to their centers.
Push in your chairs. So put one tally next to November.
At one center, the children tally and graph the month of each class member's birthday. In another, the students identify and graph the most popular method of coming to school. In a third, the children call to compare the prices of pizzas.
Hello, this is Jenny Peters from Webster Elementary School. I am a student in Mrs. Bush's class. We are pricing pizza. Please tell me how much is a large pepperoni pizza would be.
They graph the prices to help them decide where they should shop for a pizza. They enter the prices on one of the classroom computers, which creates bar graphs for comparison.
Yeah, okay, I can't play now.
At a fourth center, the children use a video disc to measure and compare the times children take to run an exercise course. They then graph and compare the times.
She's wasting time. She was later than that other boy, but she did get there first. Look! I know what she got there first, but she took longest.
1 minute, a minute and 10 seconds.
As Sue's time for math is nearly over, let's see how she brings her lesson to closure.
When we set up a problem, what do you have to do in order to solve the problem? Timmy?
Add or subtract.
Okay, but you have to decide what before you add or subtract. Okay, so we have to collect the information, and then we have to organize it. And we organized it by setting up a bar graph. It's a nice way to look at information and make decisions about certain things. That's what you were doing at your centers also. Okay, set up some really neat types of graphs. Do you have any questions about any of your centers?